It's Clive Roxinger here. I'm going to make this quick as I'm probably going to run out of camera time. I've just made a big step forward with AES. There are a lot of people that don't want this to work because they know what I'm doing. It's all starting to come to a nexus now. It's all coming to a point. All of these have been separate jobs, but I've developed them and developed them and developed them. It's now to the point where I'm going to start putting this together. Now, what I had was, what was frustrating me with this, I've done this a million times. Set up LEDs, got them working, right? Now I want to build a light for this application that I'm making at the moment, and they're the handles for it here. The handles for it's a workstation. We're working with Arduino. But I want a full comprehensive lighting, and I want to design a light system myself. Now, I can't find anything on the net where they actually show you how to do this. Even though they kind of will, they only do it for special applications. Now, the first thing you're going to have a problem with is this. As soon as you get a circuit like that, the wattage goes up and you fry these things. They can only handle very light wattage, right? So what I did was I designed these things. And what that can take is different types of batteries. And the terminals that connect this up are these things, real high wattage. And these you can buy anywhere. This is public sector science. So I want to make darn sure you can buy this anywhere. I'm in the automotive game. You can go to a grocery store and buy these things. They're so common. These are just fuse holders. They have them in every mechanical, every mechanic shop, every panel bearer has got a box full of these. They're easy to get. And so what you do is you make your own battery holders, right? Now that's to take different size. It's a rechargeable, and I can actually change that battery over. You pull that little lid up there. I've got to undo that screw at the back. These have got my own terminals. They're really cheap terminals. All they are those little things, and what I do is I tighten them up with a vise. They're really easy to put on. So the bottom line now is what I'm finding here is I've got an application where I need a fair bit of power, and I need 3 of these batteries. And what I'll do is I'll go vertical with that. And so the batteries will, I've got to turn that on a right angle, that bolt up, and put the batteries in on the side, sort of thing, or actually have it like that, and go vertical with the batteries. They actually might have to be in line with the batteries, I'm not really sure at this stage. But the idea is I make my own battery pack up, and that way I can control the wattage. So I can get a huge amount of wattage going through this stuff, because even though it's in PLA, the actual connector is an actual screw. It's one of those little electronic screws, the chrome ones, that's making the contact. So this can really handle a lot of power. You put like 30, 40, 50 watt through that, no problem at all. You can have about 20 batteries in whatever combination. And that's the whole idea of this. You put it in different combinations. That's what this is. This setup here is to change the combinations of the battery assemblies. And that's what that's for. All these jumpers that pull out. And that's to change the configuration of your battery setup. Now I've got this one here and I want to build this circuit and I want to make a light. So I thought, how do I make the light up? You know what it is? It goes into one of these boards. That's all this is one of these. This is my light here a high powered one that just fried and I bought a new one. Now see that? See the bakelite type of board? And that's all that is if you pull that off, that's just the LEDs. LEDs sitting on top of that little board. That's all it is. It's just the LED sitting directly on top of that board. It's sitting on top of this. I won't do it exactly like that. I want to have these, when I put the LED through, I'm going to put those wires to the side a bit so I can wire it up, and it's all, I like it all geometric. And the size of the light will probably be a bit big. It'll probably be about the size of that white square. But there'll probably be, 10 LEDs in there, and I'll be able to individually switch each one. And any power requirements can be any configuration that I decide to make up, and this can account for all your internal resistance. That's to test, internal resistance. And what I'll do now is I've got this circuit here that I built, and I kept track of how I did it, and now it goes up to this phase, which is this one. I do a bolt-up assembly of it. I do a complete circuit diagram of it. I do all the math with it, and every time I want to do a new configuration, I 3D print a board, and I 3D print those now. I can 3D print these little boards, and I'll make that up into a circuit and screw it together, and I'll have a whole bunch of paperwork with calculations, and every time I do a new configuration I can redesign the circuit, 3D print myself up a little board which is actually a simulation of that, and as you can see on this, I know what it is. That's the one there, that's the circuit there, what the book I got it out of. So this is working brilliantly well, and you can go to the point where you can go on a mass production. I could sell these. I could sell these and they'd be quite okay to sell. And everything you can buy over the counter. So they don't teach you this. This is the way I'm going to be teaching AES. These are useless, because as soon as you get any sort of power in the circuit, that's going to fry. Look at the size of the terminals, the wiring in there. That'd only handle, you know, a few watt, and that'd fry. So these things, on the other hand, they're automated. They can handle up to 20 amp. So there's no worries there. So you can put quite a bit of wattage through those. And I can also, and I make up these little things here. That's what that is. So that in actual fact is that. That thing there is actually that thing there. But it's got removable jumpers, so you can change the configuration. And when you get rechargeable batteries, they don't charge up full, right? So what you do is you run, instead of running 3, you run 4, and then you put a trimmer or something on it so that you can regulate the end voltage so it doesn't exceed the maximum voltage of the device. And you can have a battery pack that runs at full power all the time that uses rechargeable batteries. They often say don't use rechargeable batteries because they don't charge up full. Put another battery in there. And you can do that with this configuration here. So that's going to get redesigned now, and I'm going to make a triple stack and put 3 batteries in. I've already designed it to take the bigger one, and now I'll design it to take the 9 volt and all that, and I'll be able to reconfigure them in series, parallel, whatever combination I want. So yeah, this is the way you need to be going with this stuff. And then when you want to put the Arduino on an actual circuit, there I've made a board up for it as well. Alright, so Clive Rocksinger over and out.